Our next type of special pattern for factoring is what's called a perfect square trinomial. With a perfect square trinomial, it actually gets its name from its factored version in part and from its unfactored version in another way. So we're going to start with a factored polynomial that is a square. So here we have 3x plus 4y times 3x plus 4y. This, of course, is also known as 3x plus 4y squared. In this sense, this is what we're going to look at when we talk about a perfect square. We're going to be squaring a binomial. If we square this binomial, we're going to do each one of these multiplications in here. So we'll do 3x times 3x plus 4y, and then 4y times 3x plus 4y. Distributing each one, 9x squared plus 12xy plus 12xy plus 16y squared. Simplifying and adding the two terms in the middle, we get 9x squared plus 24xy plus 16y squared. In the case of a perfect square trinomial, we're actually going to start down here and work our way this way. So what are some of the key characteristics of a perfect square trinomial? Well, there's a couple different things happening for a trinomial to be a perfect square trinomial. First, much like with the difference of squares, we need a square as the first term, and we need a square as the last term. In the case of the first term, 9x squared is just 3x times 3x, and 16y squared is 4y times 4y. What we need from the middle term is that we need this to happen. We need those two multiplications of the square roots from here and here to be doubled. That's what would allow us to, in a sense, work our way backwards to create the factored form. So we need this middle term to be twice the product of the square roots of the two end terms. And that's what we have here. We take the 3x, we multiply it by the 4y, and we get 12xy. That's the terms we see right here and right here. And then we double that because there are two of them, so we get 24xy. So we need a square in the first term, square is the first term, the square is the last term, and this middle term needs to be twice the product of the square roots of the outside term. If you can check all of those boxes, creating the factored form is a matter of just putting the two square roots in the appropriate places. Because the first term and the last term both have to be perfect squares, the only place that we could potentially see a minus sign in a perfect square trinomial is in front of that middle term. If that was the case, and this was a minus, we would anticipate both of those signs also being minuses or subtractions. Let's look at that going the other direction. Here we'll start with the non-factored trinomial and work to the factored one. If we start with a first term of 4x squared and we end with a last term of 16, we can check that these two are perfect squares. This is 2x and 2x. This is 4 and 4. What we want out of this middle term is to be twice the product of those two squares. And that requires us to have a middle term of 16x. If we want this to be a perfect square trinomial, you could put any number of different combinations in that middle and get it to factor with the 4x and the 16. But if we want it to fall into this specific category of the perfect square trinomial, so it ends up that its two binomials are identical, then that's the pattern that we need to follow. That's what makes it a special pattern. So that being said, we could then separate this into two different binomials based on those two squares, 2x plus 4 and 2x plus 4, also known as 2x plus 4 squared. Again, if we can identify a perfect square here and a perfect square here, and then the middle is double their product, then we have a perfect square trinomial. There are some situations that may not look like a perfect square trinomial at first, but you have to engage in some other kind of factoring to get it to cooperate into that format. Here we have an example of 108x squared minus 180xy plus 75y squared. 108 is not a perfect square, 75 is not a perfect square. But if I notice that all three of those terms have a common factor of 3 and I start there, I actually create a polynomial, well in this case more specifically a trinomial, that then does begin and end with two perfect squares. This one is 6x times 6x. This one is 5y times 5y. And then we do our check for the middle. Is the middle twice the product of those two? It most assuredly is. So I can create my factored form based off of those two perfect squares at the beginning and the end. And I know my binomial would be 6x minus 5y. So while you're looking for our special forms, something like a perfect square trinomial, don't discount the necessity to look for the greatest common factor first. The greatest common factor has a role in these, just like it did with difference of squares and just like it did in the last lesson. It may need to come first, and once it's out of the way, then you have something that you can use our perfect square trinomial understanding on to create the factored form.